Hey, Year 7s, let's take up Assessment 3. Now, if you're seeing this for the first time and maybe you just want to go through and try these questions out, you can always do that. Just hit pause, do the question for yourself, and then hit play again and see how you have done. Okay, let's get started. This assessment is going to be covering fractions, decimal percents, fractions of time, linear sequences, and angles on a straight line. This first question here is a linear sequence question, and it's asking you to work out what the nth term rule is. If you want to try that for yourself, hit pause and go ahead and give that a go. Let's have a look at how we actually did on this. Now here, these are the statistics of our results, and we can see that blank 1, so this one here, got 95.5% right. That means most of you got this answer right. Okay, blank 2 as well. Blank 3 is down to 77.3, so that's a bit lower. Blank 4 is way down here with only 59.1%. So that's quite a bit lower. That's where we're making most of our mistakes. That's on figuring out what the adjustment is. Okay, so you can see how we did on each of these blanks here, and that'll give us a little bit of an idea of how much time we need to take taking this up. Okay, so I can just show you that here in color coding. Here in green are the questions that we found quite easy. Here this is a little bit harder, and there that was very hard. So to get the 16, what we did is we looked at the pattern. We saw it 4 plus something makes 7, plus something makes 10, plus something makes 13. And I noticed that I'm always adding 3's on. So I keep going adding 3, that's 16, add another 3, that's 19. And we already know what the rule is, although some people have a hard time putting that into the actual format of the rule. We know that we're always adding 3, means our common difference is 3, which is why most people got this one right as well, although some are still struggling. Okay, so it's the number that we're jumping by. That's what goes in front of the n. So we say it's like the 3's times table, except it's not the 3's times table. The first number in the 3's times table should be 3, and this is one number higher. That's why we have to add 1 to the 3's times table to make this sequence. The 3's times table is 3, 6, 9, 12, and so on. And this is one more than those numbers. Another trick for figuring out what the adjustment is, I sent some of you this video, is simply to think, if this is jumping by 3's, what would it have started with before we had that 4? So 3 less than that 4 was 1, and that's how we can find that one. Okay, this next one, so this is blank number 5, got 86%, blank number 6 got 86%, and blank number 7, 72%. So again, the same pattern here. These ones were easier, this one was a bit harder, and this is blank number 8, which is way down here, only 27%. That's very low, so we definitely need to go through this. Okay, this first one, we can see the pattern here. It's a little bit more difficult than the one above because we're starting with negative numbers, but we can see those negative numbers are getting less negative. And that's getting even less negative. In fact, it's getting into the positives. And here with these positive numbers, it should be clear that we're adding 6. 1 plus 6 makes 7. Go back to the negative numbers and check if that's true as well. Negative 11 plus 6 makes negative 5. Yes, it does. Negative 5 plus 6 takes us past 0 up to 1. Yes, so we're always adding 6's. So if we keep going adding 6's, we get 13. Add 6 again, we get 19. And like I said, we already know what this rule is. We know what the common difference is. We're adding 6, so we should have a 6 in front of the n. That's assuming that this is just like the 6 times tables. It's jumping by 6's. However, it's not the 6 times table. It's a lot lower than the 6 times table. What do I need to take away from the 6 times table to get this sequence? Well, 6 take away 6 would get me down to 0, and I need to be 11 below 0. 6 and 11 together, that's 17. I need to be 17 less than the 6 times tables. Or that other trick I mentioned up here, if you can't find the adjustment, just think about this pattern. What would the number before negative 11 have been? It would have been 6 less. 6 less than 11 is negative 17. So it's negative 17. Right? Question C, so this is blank number 7, 8, no, sorry, this is blank number 9, 10, 11, 12. Let's look over here. 9 has got still 81.8%. 10 has got 81.8%. 11 down to the 50s again. And 12 down to 23% when we round that. That's quite low. So let's take this up. Here we see there's a pattern. I can see that it's going down. It's a negative pattern, which is why the rule is a bit more difficult to find. It's going down by how much? I've got 12, take away something makes 4. 4 take away something makes -4. -4 take away something makes -12. And I have to keep going. Notice that I'm always taking away the same value. I'm always taking away 8. So -12 take away 8 is 8 more negative than -12. -12 take away 8 is -20. Take away another 8 is -28. And as we've seen before, we already know the common difference. We know the number we're jumping by. So over here, I don't know if some of you maybe just put 8, but it's going down by 8, so it's -8. Okay, so we're going down by 8s, just like the -8 times table, but this sequence is much higher than the -8 times table. It starts with +12. If we want to use that rule that we were talking about here, that might be the easiest way to find it. If it starts with +12 and it's going down by 8s, what would the number before the 12 have been? So before we took away 8, what was it to make it 12? It was 20. It was 8 higher than 12. That was 20, right? Or also thinking about the 8s times table, it starts with, sorry, the -8s times table starts with -8. And this starts with a number that's 20 higher than -8. If we think -8 to 0 is 8, and then I need to be 12 past 0, so 8 and then another 12, that makes 20. Okay, let's go on to question 2. Okay, once again, if you want to try this on your own, hit pause, do it for yourself, and then hit play again, and you can see how you've done. Let's first see how we did on the assessment. This one went quite well for us. 90%, 91% if we round that, got the first bit right. 100% got the second right, 91% got the third bit right, and 86.36% got that last bit right. So this is our weakest one, the one at the bottom, but the rest of them were really good. In fact, they're all really good. So it shows me that we really do know this now. 1/5 we know is the same thing as if I times the top by 2 and times the bottom by 2, that would be 2/10. And 2/10 as a decimal is over here. Okay. 2/8, I can simplify that, divide both the top and bottom by 2, that would be 1/4. And 1/4 as a percentage I know is 25%, that's over here. 0.02 as a decimal is the same thing as 2 in the hundredths position, that's 2/100ths, that's 2/100, which is a percentage is 2%, 2/100, 2%. Okay, those were all the easier ones. This is our only more difficult one, really. 150/75. That's a top-heavy fraction, so you should be thinking, how many 75s go into 150? And there are 2 of them exactly. 75 times 2 makes 150, or 150 divided by 75 is exactly 2. Right, question 3. Again, hit pause if you want to. This is a good one. This is one that we struggle with fractions of time. That's why we keep seeing it. Let's see how we did this time. 95.5% got the hours right. However, working out the minutes, that's always our difficulty. Only 59% got that right. So we're trying to work out 3/5 of a day. And Andy thinks that 3/5 of a day is 14 hours and 40 minutes. Can you correct him? So I'm telling you he's wrong, so do not write 14 hours and 40 minutes. First of all, a day is 24 hours. So 3/5 is 24 hours. We do 3/5 times 24. Now to multiply by a fraction, we multiply the top by 24. The bottom we don't need to multiply because 24 wholes is the same thing as 24/1. And if I times 5 by 1, it stays 5. Multiplying that out, I get 72/5, which is a top-heavy fraction. I am expecting a top-heavy fraction because I know that this is a number of hours, should be a whole number of hours, plus some fraction of an hour, which we work out into minutes. So how many whole hours is that? How many 5s are there in 72? There are 14 5s in 72, because 14 times 5 is 70. That means that I have 2 left over 5. So the number of hours was correct. Everybody should have got that correct. Even Andy got that correct. The number of hours is 14, but we have to work out what 2/5 of an hour is in minutes. So 14 hours and 2/5 in an hour would be 14 hours and 2/5 of 60 minutes because there are 60 minutes in a full hour, and this is a fraction of that. Once again, we've done a fraction of an amount before. That means multiplying the fraction by the amount. So 2/5 times 60. And my answer here will be the number of minutes. I know how to multiply a fraction by a whole number. I just multiply the top. So that's 2 times 60 over 5. The 5 does not change, it stays the same. And 2 times 60 is 120. So I now have a top-heavy fraction. I just need to work out how many 5s there are in 120. There are 24 5s in 120. You could try doing 120 divided by 10 and then doubling that, because dividing by 10 would be dividing by a number that's 2 times as big as it needs to be. 120 divided by 10 is 12, times that by 2 is 24. So that's our trick for dividing by 5. So our answer is 14 hours and 24 minutes. Right, question 4. Again, hit pause if you'd like to try this on your own. This is another linear sequence problem. We're looking for the nth term rule. Rajiv, and you will see that name a lot. It's not a name that we are familiar with, but they use it a lot on these exams. Rajiv thinks that the nth term rule is 4n plus 2. Can you correct him? So I'm telling you he's wrong. Very often on these exams they say, is Rajiv right or is Rajiv wrong? I'm telling you he is wrong, so let's work this out. So I can see maybe where he's getting his numbers from. I can see the sequence, it jumps by 4s. But it starts with the number 2, not 4. So he's got the fact that it jumps by 4. He's got the common difference, but he's got a problem here with his adjustment. I do not need to add 2 to the 4's times table to make this sequence. Let's have a look at how we did. We got 86% right on the common difference. Rajiv got the common difference right, so we should get the common difference right. He's right to say that that's 4. However, only 68% of us got the adjustment right. And Rajiv got it wrong as well. So it is the harder thing to find. What is that adjustment? It's minus 2. This isn't the 4's times table, and it's not 2 more than the 4's times table. It's 2 less than the 4's times table. The 4's times table starts with 4, 8, 12, and so on. And these numbers are all 2 less than that. Or if you think about the rule that we had before, if this is the 4's times table, or if it's going up by 4s, what would the number before the 2 have been? Take 4 away from that 2 and you would get negative 2. Question 5. Again, a fraction of time questions, and these ones are hard ones, so go ahead and pause if you want to, and take a minute to try this for yourself. My dad got it wrong, so it's understandable that we could get it wrong as well. Let's see how we did. Blank number 1, 86.4% got it right. Blank number 2, 77.3. It's getting harder. When we're working out the hours, we've got it. When we're working out the minutes, that's where we have our problems. And then blank 3 and blank 4, we're down in the 50s and 60s down here. So these ones we need to go over carefully. It could be if you have a mistake up here, then you will definitely have another mistake down here. Let's go through this. I spent 6 hours gardening with my parents on the weekend, although to be honest, I spent 3/8 of that time playing with my dog. My dad thinks I spent 2 hours and 25 minutes playing with my dog, but he hasn't practiced working out with fractions and mixed numbers in years. So if you don't practice it, you lose practice, you forget what you're doing. So let's see if we can practice this, if we can work this out. We are trying to figure out what 3/8 of the 6 hours are. Now, 3/8 of 6 hours we know is a fraction of 6. It's 3/8 times 6. Again, to multiply by a fraction, we only need to multiply by the top. So that's going to be 3 times 6 on the top, 8 on the bottom. That's 18. 3 times 6 is 18. So 18 over 8. And that's a top-heavy fraction, so we have to think this is at least a whole hour. How many hours is that? How many 8s go into 18? 2 times 8 is 16. 3 times 8 is 24. That's too high. So 2 8s go into 18, and there's going to be something left over. 2 8s is 16, and this was 18, so that means I have 2 left over. 16 and 2 makes 18. Okay, so there's 2 whole hours. My dad was right about that bit. My dad said that it was 2 hours and 25 minutes. The 25 minutes is not right, though. Okay, so we'll put 2 hours in there. Now we need to work out how many minutes that is. 2 hours and 2/8 of an hour is the same thing as 1/4 of an hour. I've just simplified this fraction. And I wonder if you guys can figure out why my dad thinks that the number of minutes is 25. Could it be because 1/4 of an hour is 0.25? He might have made that mistake. Maybe he used a calculator when he should have been doing mental calculations. Okay, so we know that a quarter of an hour is not 25 minutes. In fact, you should know what a quarter of an hour is looking at the clock. But we're going to work it out in case you don't. So a quarter of an hour is a quarter of 60 minutes. 1/4 of 60 is 1 times 60 on the top, and we're dividing by 4 on the bottom. Or simply just 60 divided by 4. And 60 divided by 4, I hope you remember that time on a clock is 15. 15 minutes is a quarter of an hour. So my dad's wrong about the minutes, but he's got the hours right. 2 hours and 15 minutes. Okay, on to part B. If you got part A wrong, you will probably have part B wrong as well. Because the easiest way to work out what part B is, if I was playing with my dog, wasn't playing with my dog, I was actually helping pull weeds. How much time did I spend pulling weeds? I would have spent the rest of the 6 hours pulling weeds. So I would have to do 6 hours minus the time I spent with my dog, and I hope that I've got that time right, is this time I spent pulling weeds. Okay, so I'm going to do the rest of the time is 6 hours minus the 2 hours and 15 minutes. I can work out the hours, but be careful that's not my final answer. 6 hours take away 2 hours is 4 hours, but I still need to take away, not add on, take away the 15 minutes. 4 hours take away 15 minutes, that might be difficult to do. So I'm going to say it's going to be less than 4 hours, it's going to be 3 hours, and let me work out the minutes. 4 hours is the same thing as 3 hours, and a whole other hour is 60 minutes. So I'll say that that's 3 hours and 60 minutes minus the 15 minutes that I need to take away. That'll be 3 hours and 45 minutes. Okay, so my time pulling weeds is 3 hours, 45 minutes. Oof, that was a hard question. Let's go on to the next one. Okay, supplementary angles. I think this one went better. Let's have a look at how we did. Yes, it did go very well. Blank number 1, 91.3% got it right. Blank number 2, 87%. And in fact, all of the other blanks, 87%. So it's very good. It's not just the answer that we're getting, but also showing the working. So I hope that you did this. Show your working on paper, and that's the way you're always showing your working. Don't get into bad habits now. It'll only make it more difficult for you next year. Okay, so I know that this is a straight line, and angles in a straight line add to 180. So if A plus 42 makes 180, A by itself, I need to move the 42 to the other side, but make sure you keep the right order. The 180 is there first, 180 minus the 42. And if I do that calculation, A will be 138. Well done on that one. Next question. Okay, another straight line one. This one's a little bit more complicated though because it involves a lot more algebra. I've got 3 angles here, but 2 of these angles involve the letter A. So if I want to work out what the value of A is, just remember that if I use the same letter in the question, it has the same value. So I can work this out algebraically, grouping the letters together, the like terms together, and then sending the numbers to the other side to get the letter on its own. Let's see how we did. 100% on the first bit. Well done. 86.4. Oh, sorry, that's the second term one. The first one we got 86.4. The third one we got 68. The fourth one we got 81. We did really quite well on these, apart from blank number 6, which is this one here. I wonder why we had problems with this one here. I'm guessing it's because of our algebraic working, because our blank number 7 was better. We could find the answer, but it's the algebraic working that there was more struggle with. If you want to try it for yourself, go ahead and try it for yourself. Let's start taking this up though. Right, so looking at this diagram, I know it's a straight line, and I know angles on a straight line add to 180 degrees. This angle here with the square in it, you should know that a little square there means 90 degrees. So 3a plus the 90 plus 2a makes 180. Right, then simplifying that, how many a's is that? It's not 2. Don't say it's 2. I've got 3a just there, and I'm adding another 2 a's to that. 3a plus 2a, that would make 5a. And notice that there's no space for my 90 on this side anymore. I've moved it over already. I've already put minus 90 over there. So what comes down here is just what was above, 180, in the same order that it was. 180 was first, the 90 comes after. Okay, so I've got 5a equals 180 minus 90. Now I want the a by itself. So first I'm going to work out what this is. 180 minus 90, that's 90. And taking the 5 from in front of the a, that's multiplying. It goes to the other side. And I can see by this little line here, I'm writing it as a fraction. It's going to be divide by 5. So I've got 90 divided by 5, and my final answer, which actually was a lot easier for many of you than working out that 5, is 90 divided by 5 is 18. So A is 18 degrees. It may look bigger than 18 degrees because this is 3 times A and this is 2 times A, plus this diagram's not to scale. But A by itself is 18 degrees. Okay, next question. Oh, that's it. Okay, so I hope that you now understand everything in that assessment. I know a lot of you did really well with it, and some of you might want to go over the video again for a second time.